Okay, this is the second part of the 4.5 Alg1 notes. So we've got a little more vocabulary to learn. So the first word we need to learn is interpolation. Let's go ahead and just write these down real quick and then we'll talk about them. We're also going to learn about the word extrapolation. All right, pause the video if you need to, but let's talk. So interpolation is when you use a graph or an equation to approximate between two known values. So like if you have data from like 2000 to 2020, and you're like, okay, I'm going to predict what it was in 2012. Okay, that's between those 2 years. And so that's interpolation. But if you're going to use it to predict, let's say, the year 2030, which was after 2020, that's extrapolation, which is when you predict outside the known values. All right, so let's talk about it with some actual numbers. So it does say that the further you get outside the known values, the less confidence you can have in it, like the accuracy of this prediction. So it says refer back to example 1a, use the equation of the line of best fit. So it wants to know the number of students when there are 17 teachers. So if we go back to example 1a, our line of best fit was this, y equals 20.6x plus 42. X was the number of teachers, y was the number of students. Okay, I'm going to write that equation right here. All right, and X was the number of teachers, and Y was the number of students. So if they tell me there are 17 teachers, then that is X because X was teachers. So I would just plug in 17, and then I type that into my calculator, and I get that there's 392 students when there are 17 teachers. Now, if you look at our data on example 1, okay, our data, 17 is between the known X values. The X values went from 10 to 18. So 17 is in between this range of known X values. So that's interpolation because you are using an equation to like evaluate in between two known numbers. Now it wants 20 teachers. Teachers is X. So once again, we use our equation and we plug in 20 using the calculator to evaluate it. And we get 454 students. And so if you look, once again, back at that table, 20 is outside the range of known numbers. We knew schools that have 10 teachers up to 18 teachers. So 20 is past 18, so that's extrapolation. So it says, which scenario is interpolation? And that was the 17 teachers. And that was because it is between the 10 and 18 teachers. They had anywhere from 10 to 18. And then extrapolation was the 20 teachers. And that was because it was outside the data we had that covered 10 to 18 teachers. Because it went past the data we knew. Okay. And then a little more vocabulary is causation. So causation is when one variable causes a change in the other. Causation can produce a strong correlation, meaning they're very much related, and the reverse is not true. So just because they show correlation, just because they have a strong R value, does not imply that one variable caused it to happen. So an example of correlation with causation could be cars in the parking lot, like at a mall, and number of people inside. So like there's probably the more cars you see in the parking lot, the more people are inside. So there's a correlation, meaning a relationship. And it probably did cause it because as more cars came, they brought more people. So it did cause more people to be inside. Now, an example where there's a relationship, a correlation, but there's not a cause, would be the temperature and the number of shark attacks. So, for example, as the temperature increases, there's more shark attacks, but there aren't more shark attacks because the temperature increased. It's probably more like the temperature increased, and so there are more people in the ocean because it was a nice day, and so there are more shark attacks. but just the change in temperature doesn't make the sharks attack more. Okay, so let's do these examples. Time spent exercising and the number of calories burned. I bet there's a positive correlation. I bet as you exercise more, you burn more calories. So I'm sure there's a relationship, and it's positive, meaning more exercise is more calories. And I bet it's also, it says, is there a causal relationship? Not casual, causal, like it causes it. So, I bet there is a causal. And the reason is, as you exercise more, it causes you to burn more calories. So the exercising causes the number of calories to change. Okay, how many banks there are in the population of a city? I bet there's a positive correlation, meaning a positive relationship. So like as you get a bigger city, I bet you get more banks just in general. But the like building more banks doesn't cause your population to increase. So like just because you build more banks doesn't mean you have more people move in. It doesn't attract people. So I don't think it causes the population to change. Okay, time spent babysitting and the amount of money earned. All right, I bet as you spend more time babysitting, you earn more money. So it's a positive correlation or a positive relationship. We're going to try to use the word correlation. Positive correlation, and it is causal because the more hours you work causes you to earn more money. Like every hour you work more, you get paid more money. All right, and time spent on social media and your GPA. All right, it could be negative. We don't know. What I mean by that is as you spend more time on social media, your GPA might drop because you're not doing as much homework. All right, but it is not causal because just the time spent on social media doesn't cause your GPA to go down, right? You could be like an excellent student or in easier classes or just in classes that don't require homework, and your social media use might not be causing your GPA to be less than someone else's. But if I had to guess, it could be a negative correlation, meaning that, someone who spends 5-6 hours a day on social media is going to have a lower GPA than someone that spends no time on social media.